guys, and welcome to determining the end behavior of polynomial functions given a polynomial function. So what this is going to do is this is going to give us a general idea of what a graph of a polynomial function will look like without us having to graph millions and millions of different points. Okay? So we have a little key over here that's going to tell us what we do in every situation. This is what we're going to look at to answer any problem that we have. There are a few vocabulary things that are very important to get clear first. First of all, the degree. So what the degree of a polynomial function is its largest exponent. So, for example, in number 1, you've got the exponent 5, and then there's no exponent for the x, which means that it would be a 1. 5 is the largest, so this should be degree 5. Same thing. So number 2, you look just at the exponents. We've got x to the 17th. X cubed, and then just x by itself. The largest exponent is 17. Usually when you look at a polynomial function, the largest exponent will be written first. This isn't always true, but it's a good bet that that will often be the case. Okay? And then the other word here is leading coefficient. It's kind of what it sounds like. Okay? So if you have a polynomial function written in order so that the degree is first, then the leading coefficient is the first coefficient. So in number 1 here, the coefficient is that invisible 1 that would be with the x to the 5th. In number 2, it's negative 6. Alright, so let's go ahead and look at what these can tell us. Alright, so if we look here, we've got a leading coefficient of positive 1 and a degree of 5, which is an odd number. So we go over here and we find, alright, so that's an odd degree and a positive leading coefficient, which means this is what the graph is going to look like in general. That just tells us this is in general what the graph is going to look like, and then we want to be able to say that in words and not just by drawing a picture. So what we can say is that f of x, remember that's the same thing as y, goes to negative infinity as x goes to negative infinity. What that's saying is that as x gets really, really negative, y is also going to get really, really negative. And the same thing over here, alright? So f of x goes to positive infinity as x goes to positive infinity. So as x gets really, really positive, y also gets really, really positive, alright? So notice that the two ends are going in opposite directions, alright? But x and y are doing the same things, right? So as x gets negative, y gets negative. As x gets positive, y gets positive. So we would write here, if this were the question asking what the end behavior does, we would write that f of x, we would write that f of x goes to negative infinity as x goes to negative infinity, and f of x goes to positive infinity as x goes to positive infinity. Okay, so we just write out exactly what it says in that picture right there, and that would be our answer. That's all we need to do for this type of problem. Alright, so let's look at number 2. Let's figure out which case this is. So we've got now 17 is our degree. That's odd, but we have a negative leading coefficient this time. That means we're looking over here at this picture right here. Alright, so remember last time we said that they go in opposite directions, but that x and y are doing the same thing. When your degree is odd, but your leading coefficient is negative, they're still going to go in opposite directions, but x and y are also doing opposite things. Alright, so as x goes to negative infinity as we go off to the left here, then f of x is going to go to positive infinity. It's going to get higher and higher, and then the opposite there, alright? So always, whenever you have a negative leading coefficient and an odd degree, you're always going to have as f of x goes to positive infinity as x goes to negative infinity, and then the opposite, f of x goes to negative infinity as x goes to positive infinity. Alright? So now, as you may have guessed, we're going to have kind of a flippy thing going on here with the even degrees, and the even degrees have the ends going the same way. When the leading coefficient is positive, they're both going to be going up. When the leading coefficient is negative, they're both going to be going down. So again, we just write it exactly as it's written here. Same thing. I'm not going to write them out again. You can see them right there. So here would be the answer for number 3, and here would be the answer for number 4. Alright, and that's it.